let's have a look at how to sketch slightly more complex functions. This here is a cubic. We can see it's a cubic because if I were to expand this, and bear in mind I'm not going to expand this at any stage, if we were to expand it, I would get an x times an x times an x. That's the most x's I can multiply together, and that would give me x cubed. So this is what we call a cubic. It's something which would have an x cubed as its most powerful term. Okay, so bearing in mind that we're sketching a cubic here, let's think what we know about this function that will allow us to sketch it. We already know when we have a quadratic and it's factorised that those factors can tell us where the roots are. So if we consider where the roots to this equation are, again, by roots we mean where does y equal 0, we know that y can only equal 0 if one of these factors is itself 0. There's no other way to multiply stuff together and get 0. So if x plus 4 is 0, we know that x must be minus 4. If x plus 1 is 0, we know that x must be minus 1. And if x minus 2 is 0, we know that x must be positive 2. Remember, this is just a sketch, so we don't need to worry too much about the scale, just get it roughly correct. Okay, so we've got our x-intercepts by setting y to 0. The next step would probably be to set x to 0 in order to find the y-intercept. Your first instinct may have been to expand all of this and then look for the plus c at the end. That will work, but it's much harder than it needs to be. So remember, y-intercept is where x equals 0. If x is 0, then this bracket here, this factor here is just worth 4. This next factor is worth 1. And this next factor is worth minus 2. They're all multiplied together, so when x is 0 we would get 4 times minus 2, which is minus 8. And you see I'm not worried too much about my scale, just as long as it's on the right side of the axes, and that's fine. Okay, so now how are we going to sketch this? We know we need to pass through these points, but how do we do it? We need to consider one more aspect of a cubic. Like we said, x cubed will be our highest power. So if we imagine what's going to happen for very high values, we can essentially ignore any lower power. A number cubed, a large positive number cubed, is going to be much, much larger than even a large positive number squared, and certainly the large positive number itself and any constant. So basically, if we did have some extra terms here, we can essentially ignore those for very large values of x. Now let's think what would happen to a large positive number cubed. A large positive number times by itself, and then times by itself again, is now very large and still positive. So our graph should be tending up here for large positive values. Now let's think what would happen if the x value were large but negative. Again, we can ignore all of those terms. They're going to be much, much smaller. A negative number cubed, a negative times a negative times a negative, will still be negative. So our graph for the negative values should tend down here. So what that means is our graph should come from very negative values. We then know it has to pass through here, which means it must turn around. You'll often hear maths teachers refer to this as a turning point. It's a point where our graph turns, and then we know it needs to pass through minus 8, and then it must turn again because it needs to pass through 2, and then it tends towards very large positive values. In general, that is the shape of a positive cubic. Large negative values will still be negative, large positive input values will still be positive, and we must pass through these points in between. If you find that for some reason you can't pass through all of those points, it may have been a negative cubic, one of those x terms may have been negative, in which case it would have looked like that. Large negative values cubed would have been negative, but then we take the negative of that, which turns it positive. It will essentially flip our graph. But we'll discuss more about that later.